Okay, children, we have discussed the first property, that is, if we interchange rows and columns, of a determinant with the help of 2 by 2 matrix, we have seen the value of the determinant does not change. In other words, the determinant of A is same as determinant of A transpose. So now, if we take a matrix B, suppose 1, -1, 2, 4, 3, 0, 2, 3, -5, and we try to calculate its determinant, then we'll write the two vertical bars. Okay, then we'll write the determinant 4, 3, 0. Here it is 2, 3, -5. So very clearly we can expand this determinant along any row or any column, and to minimize the time we can expand it along that row or that column along which there are minimum number of elements. For example, in second row there are minimum number of non-zero elements. There is one 0 over here, so we can expand it easily along this, because only this cofactor and cofactor of this element will remain and this element will not be there. In the same way, in the third column we can see the same picture. This element will be multiplied with the help of its own cofactor, and this element, or we can say that it's minor determinant, and also this element will be multiplied with the help of its minor determinant. The minor determinant of this element, that is 1, -1, 2, 3, will be there, but after getting multiplying with 0, it will vanish. So in third column we can see that the second element will vanish and first and third element will be there, and in the second row first and second element will survive. The third minor determinant will multiply with 0 and get vanished. So let us calculate this determinant along any row you wish, first row, or any column you wish. But now I will calculate with second row. So it is equal to second row. First I will write all these elements 4, 3 and 0. Since it is 0, so I am not going to do anything over here. 4 is there in the arrangement second row first column. So 2 is the row and 1 is the column. 2 plus 1 is 3. So -1 raised to 3 is an odd number, that is -1 getting an odd location. So I'll write minus over here. I'll supply this 4 with the help of its minor determinant. I have to hide this second row and first column. So what elements I'll get? -1, 2, 3, -5 as a minor determinant. This I will get it as a minor determinant. This I have got by hiding that particular row and that particular column in which element 4 is located. Then I'll add plus. Then again 3 is located in the second row second column position. So -1 to the power I plus j, ith plus jth row, ith row plus jth column. So that is second row second column. So it is an even location. 1 plus 1, 2. So hence it is positive 1. So there is no need to write minus sign over here. Already 1. It means 1 into 3, 3. Then I'll supply this 3 with the help of its corresponding minor determinant, its cofactor, or you say the codeterminant, which is obtained by hiding second row and second column. That is nothing but these end elements 1, 2, 2, -5. 1, 2, 2, -5. But I did not write, but for your explanation, for your understanding, I'm writing this. For the last, I'll write 0. Again, there is an odd position. It is in the second row and third column. So 2 plus 3, 5. So -1 to the power 5. So it is again -1. But it will not make difference because already it is 0. So I am not writing -1 over here. If you want, you can write it. We write it with the help of a bracket sign -1 into 0 into determinant. Now here which determinant will come? After hiding second row and third column, I will get this 1 -1 2 3. 1 -1 2 3. So then now I am able to find out its value. -4. It will be 5. 3 2s are 6. Then plus 3 times 1 into -5 will be -5. 2 2s are 4. -4. And this is 0. Then we have, this is what? -1. -1 into -4 will be 4. Then here -5 -4 will be -9. It will be -27. So I have got the answer as -23. Now we will see how to calculate it after changing its rows and columns. So I'm turning the page with the same or I'll take the aid of one more page and I'll see how to calculate its value. So I have got same matrix B, but now I am changing its rows into columns and columns into rows. So that means indirectly I am trying to calculate its transpose, finding its transpose. So its first row will become first column, second row will become second column 4 3 0, and third row will become third column 2 3 -5. And now I am in a process of calculating its determinant. Again I will write it in the form of determinant -1 3 3 2 0 -5. I'll try to find out its value. So again, calculating through any row or any column. Earlier we have seen calculating through that row or that column in which there are minimum number of non-zero elements. But it's not hard and fast. You can calculate with any row or any column. So generally students, they try to hit the first row only. So let us calculate in that way. So first I'll write all the elements 1, 4, then 2. I'll supply the location elements. What is that location element? Location sign plus minus plus minus plus minus plus minus plus. So for the first row already we have got plus, then here it will be minus, then here it will be plus. Then I will supply with the help of its minor determinants. So what is the minor determinant corresponding to element 1? By hiding first row, first column, I'll get 3 3 0 -5. 3 3 0 -5. Here also I will get, for 4 I'll have to hide first row and second column. So -1 3 2 -5. -1 3 2 -5. Here for 2 I have to hide first row and third column. So it is very easy. -1 3 2 0. -1 3 2 0. Then I will try to compute what is the actual determinant, called as determinant of B transpose, or determinant of that particular matrix, by getting, when you change the rows into columns and columns into rows, interchanging rows and columns. So it is 3 5s are 15, -15 you will get -0 -4 times. Here -1 into -5 will be 5 -6. So it will be 5 -6. I'll write down like this. Then plus 2 times -1 into 0, it will be 0 -6. So it will be -6. So what is the final answer? -15. This will be -1. -1 into -4 will be +4. Then here it will be 2 into -6 will be -12. So here we have got -15, -12, -27 plus 4. Again we have got -23. So we have got here, we were getting the determinant of B as -22. We were getting determinant of B as -23, and we have got determinant of same matrix after transposing, after interchanging its rows and columns. You can see we have interchanged the rows and columns. We have seen minus 1, 1, minus 1, 2. This row was becoming this column, and this second row was becoming second column, and third row was becoming third column. We have calculated the new matrix. Its determinant we have calculated. We have got minus 23, and here we have obtained the determinant of original matrix, which is minus 23. Hence we can say that the determinant of we can say that determinant, which is equal to, I can say like this, it is equal to determinant of B transpose. Hence I will write determinant of B is same as determinant of B transpose. So thus we can say that the value of the determinant remains unchanged or remains same if its rows and columns are interchanged. We take an example in the next video.